Every loaded truck on the interstate tonight rides on one part almost nobody will ever see. It is a single joint spinning under the floor, taking thousands of pounds of force as it bends the engine's power toward the wheels. The farm boy who invented it earned 27 patents, and his name still rides under nearly every heavy truck in America. Yet he lost the company he built, watched his name come off its own gates, and died almost unknown. So how did the man who made the joint the whole country runs on vanish inside his own invention? Clarence Winfred Spicer was born on November 30th, 1875, on the open farmland near Edelstein, Illinois, the third of 4 children. His father ran a creamery, and that small fact shaped everything that came after. A country creamery in the 1880s was really a small factory. Separators spun, belts slapped, churns turned, and steam hissed through the whole building, and every piece of it was prone to jamming or breaking down at the worst possible moment. Clarence grew up inside that noise. While other boys did chores, he watched his father pull machines apart and put them back together, and he learned the language of moving parts before he ever learned much of anything in a classroom. He understood, early, that power had to travel. It came off a steam engine or a turning wheel, and somehow it had to reach the thing that needed driving. When that path of power broke, the whole operation stopped cold. In 1891, his family sent him east to the Alfred Academy in New York, a school tied to their Seventh-day Baptist faith. He was a careful, quiet student with a gift for anything mechanical. But the schooling did not last. In 1894, his father was hurt in a farming accident, and Clarence came home to Illinois to keep the family business running. Therefore, the boy who loved machines spent his early 20s not designing them, but nursing worn-out creamery equipment through one season after another. He married Anna Olive Burdick in 1896, and for a while it looked like the farm would simply hold him. But the pull toward engineering never let go. In 1899, at the age of 23, Spicer enrolled at Cornell University in the Sibley College of Mechanical and Electrical Engineering. He arrived older than most of his classmates, a married farmhand sitting in lecture halls full of younger men, and he brought with him something they did not have. He had spent a decade watching machinery fail in real life, not on paper. At Cornell, an assignment landed on his desk that would decide the rest of his life. Students were asked to design a self-propelled automobile, a working motor car, at a time when the automobile barely existed. Most of his classmates treated it as a paper exercise. Spicer treated it like a problem from the creamery floor. He started asking the question that had followed him since boyhood. How do you get power from an engine to a set of wheels without the connection shaking itself to pieces? He was not alone in the work. The dean of Sibley College was Robert Thurston, one of the most respected engineering minds in the country, and Thurston saw something in the quiet student from Illinois. He encouraged Spicer to keep pushing on the idea, to treat it as more than a grade. Neither man knew it yet, but that motor car assignment had uncovered a flaw sitting underneath every automobile then being built, a flaw that nobody had solved, and Clarence Spicer was about to spend the next year of his life chasing it down. To understand what Spicer found, you have to understand how a car moved in 1900. The engine sat in one place and spun. The wheels sat somewhere else and needed to turn. The hard part was the distance between them, because the axle rode up and down over every rut and stone in the road, while the engine stayed bolted still. The connection between the two had to deliver power and bend at the same time. Most builders of the day solved it with chains and sprockets, the same idea as a bicycle, only heavier. A chain ran from the engine back to the rear wheels, out in the open, exposed to mud, grit, and rain. It was loud. It stretched. It threw off its sprockets on a hard bump, and when a chain let go at speed, it came apart with a sound like a whip cracking across the frame. The whole arrangement was crude, and every engineer building cars knew it. The universal joint itself was not a new idea. The basic design of a flexible coupling was centuries old, sketched out long before the automobile existed. But nobody had made one that could survive under a car. The early versions ran dry and open, the same as the chains, and they wore out fast or shattered under load. Therefore, the joint that should have replaced the chain kept failing in exactly the same way. This was the flaw Spicer chased. His answer was to take the drive shaft and connect it to the engine at one end and the rear axle at the other, using a universal joint sealed inside a housing, enclosed. protected from the road, packed with lubricant instead of running dry, a spinning shaft that could bend at the joint, flex as the axle moved, and still carry every bit of power straight to the wheels, quietly, without throwing itself apart. The part did its work where no one could see it, and that was the point. In 1903, he built an experimental car of his own to prove it, and it worked. The shaft ran smooth where a chain would have rattled and slipped. On May 19, 1903, Clarence Spicer received a United States patent for the first practical automotive universal joint. He was still a student. He had not yet finished his degree. But the moment he succeeded, the ground shifted under him. That same October, Dean Robert Thurston died. The one man at Cornell who had pushed him forward, who had seen the idea as something larger than a classroom grade, was gone. Spicer was left with a patent, a proven design, and no mentor to tell him what to do next. So he made a decision that should have been reckless. He walked away from Cornell in his final semester, degree unfinished, to manufacture the joint himself. He was a gifted engineer with a part the industry needed. He was also a farm-raised inventor with no money, no factory, and no idea how to run a business. He could design a joint that would outlast the car it was bolted into. Whether he could build a company that would outlast him was another question entirely, and one he was not equipped to answer. That gap between the brilliance of the invention and the man's grip on the business would shadow the rest of his life. For now, none of it slowed him down. Spicer had something automakers wanted, and word of the sealed joint was already starting to travel. On April 1st, 1904, Clarence Spicer opened for business. He did not have a factory of his own. What he had was an arrangement with the Potter Printing Press Company in Plainfield, New Jersey, which let him work out of a corner of their building. He moved Anna and their 3 children from Ithaca to start over in a state where he knew almost no one, betting the family's future on a single part the size of a man's fist. The bet paid off faster than he could handle. Automakers had been waiting for exactly this: a sealed joint that did not throw chains, did not stretch, did not need constant nursing. Builders began designing new cars with Spicer's joint already in the plan, and the orders came in faster than a handful of people could fill them. Within a year, Clarence, 3 employees, and a corner of someone else's factory were buried in work. Therefore, he did the thing every growing operation has to do. He went looking for money and structure. On May 25, 1905, he incorporated the business as the Spicer Universal Joint Manufacturing Company, a name that said exactly what it sold. Incorporation brought in financing, and financing brought in capacity, and capacity let him chase the demand that kept climbing. Sales doubled inside 2 years. The work itself was punishing: forging steel, machining the crosses, and bearing cups to fine tolerances, heat treating each piece so it could take the pounding of the road. A universal joint is a small thing, but it lives a violent life. It spins thousands of times a minute and absorbs every shock the wheels send back up the shaft. A loose tolerance or a soft batch of steel meant a joint that failed in the field, and a joint that failed in the field meant a customer who never came back. Spicer knew his whole name wrote on parts most drivers would never look at. By 1909, the company had grown enough that the long original name no longer fit. He shortened it to the Spicer Manufacturing Company. The same year, the operation was straining against the walls of its borrowed and rented space. Spicer needed room, and he needed to be able to move steel and finished parts in volume. So in 1910, the company moved to a new site in South Plainfield, New Jersey, set deliberately alongside the Lehigh Valley Railroad. Raw material came in by rail, finished joints went out by rail, and the factory sat directly on the artery that fed it. The little corner operation from 1904 was now a real manufacturer with its own building, its own rail siding, and a product spreading under more American cars every year. And the timing could not have been better. The automobile was no longer a rich man's toy. Production was exploding across the country, and nearly every one of those cars needed a way to send power to the wheels. Spicer had the answer, patented and proven, and for a few short years it looked like the path ran straight up. But growth has a cost, and the cost is cash. Every new order had to be financed before it could be filled. Steel had to be bought, workers had to be paid, and machinery had to be added. All of it spent long before the customer's money came back through the door. The faster Spicer grew, the more money it took just to stand still. The invention was a triumph. The balance sheet was a different story. Clarence Spicer was an inventor first and a businessman second, and the gap between those two things was beginning to show. He could keep designing better joints. He could not, on his own, keep feeding the machine he had built. By the years just before the First World War, the company that carried his name was running short of the one thing no patent could supply, and help, when it finally came, would arrive with a price. The man who answered the money problem was not an engineer. His name was Charles Dana, a New York lawyer and businessman with a sharp eye for a company worth saving. By 1914, Spicer's situation was plain to anyone who read the books. Here was a product the whole industry wanted, attached to a business that could not raise the cash to make enough of it. To Dana, that was not a failure. That was an opportunity. Dana brought in capital, and capital was exactly what Spicer needed. But money like that never comes free. It came with control. Dana took a leading role in the company's direction, reorganized its finances, and steadily became the figure steering its future. The arrangement saved the business. It also began, quietly, to push the inventor toward the edge of his own creation. This is the turn the whole story bends around. Clarence Spicer had built something the market could not get enough of, and that very success was what loosened his grip on it. He had the patents and the engineering mind. He did not have the financier's instinct for raising and managing money at scale, and in the end, that was the skill that decided who held the wheel. The joint would outlast the car. The company would outlast the man who founded it. But Spicer himself would not be the one running it. He kept doing the thing he was born to do. He kept inventing. Over the span of his career, he was issued 27 United States patents, along with several in France, and he stayed close to the engineering side of the company for years. He earned the respect of his profession and served as an officer of the Society of Automotive Engineers. The work never stopped, but the business had moved beyond him, into the hands of men who thought in balance sheets rather than bearings. The years went on, and Clarence Spicer slowly faded from public view. The company carried his name across its gates and its catalogs, but fewer and fewer people connected that name to a living man. He had become, in a sense, exactly like his invention. Present everywhere his joints were sold and noticed almost nowhere. On November 21st, 1939, Clarence Spicer died in Florida, just shy of his 64th birthday. His joint was by then under a generation of American vehicles. His patents had reshaped how power reached the wheels of nearly every car and truck on the road. And yet, he died the way he had lived for years. In the background, a quiet man whose name was far more famous than his face. The invisible joint had a perfectly invisible inventor. 7 years after his death, the company finished becoming something he would barely have recognized. In 1946, the Spicer Manufacturing Company was renamed the Dana Corporation, in honor of Charles Dana and his decades at the helm. The man's name came off the masthead, but it did not disappear. It moved. From that point on, Spicer became the brand stamped on the driveline itself, on the joints, the drive shafts, and the axles that carried power to the wheels. And the timing pushed it further than Clarence ever could have. During the Second World War, the company had turned its machines toward military work, building driveline parts for the Jeeps and trucks that carried American soldiers across 2 theaters. When the war ended, that same hardware went looking for civilian work, and it found the open road. The country was about to be tied together by highways, and the freight that moved across them rode on heavy trucks. This was where the Spicer joint came into its own. A loaded long-haul truck is the hardest test a driveline will ever face. Enormous weight, constant torque, thousands of miles between rests. The sealed, lubricated joint that Clarence designed to survive a country road in 1903 turned out to be exactly the principle a 40-ton truck needed to survive an interstate. The company leaned hard into heavy trucks, off-highway machines, and farm equipment, the toughest jobs power transfer has to do. Follow the badge forward, and it never really stops. Today, the Spicer name still rides under the heaviest trucks built in America, supplied to the biggest names on the road: Freightliner, Kenworth, Peterbilt, Mack, and more. Dana grew into a global parts maker, doing on the order of $10 billion in business a year, and the driveline still carries the name of the farm boy from Illinois, who started it in the corner of a printing shop. Every one of those trucks runs on the same basic idea he proved with an experimental car more than a century ago. Power has to travel, and it has to bend on its way to the wheels. Spicer solved that once, cleanly, and the solution was so good that the industry simply absorbed it and stopped thinking about it. The highest praise an invention can earn is to become invisible. By that measure, few inventors ever succeeded like Clarence Spicer. Somewhere on the highway tonight, a loaded truck passes, and the part doing the hardest work makes no sound at all. Under the floor, between the engine and the wheels, a sealed joint is spinning and bending exactly the way one farm boy worked out on a Cornell drafting table more than 100 years ago. It carries the weight of the freight, the truck, and the whole road economy that depends on it, and it does the job without a sound and without credit. Clarence Spicer never wanted to be famous. He wanted the joint to work. It worked so well that the world forgot the man and kept the part. That was the trade. And every mile, on every interstate, his invisible joint is still quietly holding up its end of it. If you ride these roads, or you grew up around the machines that built them, this channel is for you. We dig into the forgotten engineering and the overlooked people behind American trucking and railroading, one story at a time. Subscribe and keep watching. Up next, the story of another part you have never thought about, and the men who bet everything on it.